Hi everybody. Today I have a problem on one-dimensional kinematics, specifically in the x direction. So the problem states, you are designing an airport for small planes. One kind of airplane that might use this airfield must reach a speed before takeoff of at least 27.8 meters per second and can accelerate at 2 meters per second squared. If the runway is 150 meters long, can this airplane reach the required speed for takeoff? If not, what minimum lengths must the runway have? So I highlighted the important information here. Must reach a speed before takeoff of at least 27.8 meters per second. So that is something to keep in mind, that if the plane is to go off properly from the runway, that is the minimum required velocity. We also see that it says accelerate at 2 meters per second squared, so we know that acceleration is 2 meters per second squared. I can write that down immediately. And we're focusing on A right now, so let me put A. So if the runway is 150 meters long, so this means that we are only measuring the total distance to be 150 for part A. That would be the length, hypothetically, of the runway. And we are going to see if this length allows us to reach the required speed for takeoff. And the required speed, remember, let me put velocity required below R there, is 27.8 meters per second. So to solve this problem, if we look at the equations, what we're trying to find is what the velocity will be at when the runway is only 150 meters long. So we could use this equation here. V squared is equal to V0 squared plus 2a change in distance. We would use this because what we're looking for is V. We know what the initial velocity is, it's just 0. We know what the acceleration is 2 meters per second squared, and we know what the change in x is, which is 150. So change in x, remember, is equal to x, it's a weird, x minus x0, but x0 in this instance will be 0. So it would just be x. So if we plug everything in, v squared is equal to v0 squared, so 0 plus 2 times 150. And now I'm going to take the square root of this. So this is going to be equal to 600. The square root of 600 is 24 point, let's put 24.5. And you'll notice that what we're looking for is 27.8. So 24.5 is less than 27.8. So we did not reach the required speed. So the answer here would be no. We did not reach the required speed. So if we go to B and try to find how basically B states, if not, what minimum length must the runway have? So we are looking for x in this instance. We could use the same equation. So in this instance, velocity is going to be 27.8 because that's what we're looking for. Acceleration is still 2. X is what we want. So if we use the same equation, we can say 27.8 squared. Remember, initial velocity is going to be 0 again. So 0 plus 2 times 2 times x. So 27.8 squared. This is just going to get out of there. So this will be divided by 4. 2 times 2 equals 4. I'm dividing on both sides. So we get 27.8 squared divided by 4. which is 193.21. And that would be the answer. And the other answer would be here. And this is an example of a simple one-dimensional kinematics equation in the x direction.